Hey everybody, we're gonna have fun with math today. Yeah, I know, you're so excited. I love this. Every time I see a math word problem, it looks like this. If I have 10 ice cubes and you have 11 apples, how many pancakes will fit on the roof? Answer, purple, because aliens don't wear hats. That's kind of how a lot of folks are. Some of us don't struggle too much with math. I always did well with math. But some folks really do struggle, and I recognize that. I'm going to teach you some dimensional analysis today. Before we do that, though, we're just going to talk a little bit uh, about lawn maintenance in general. This math is an important part of that. A lot of us are going to be doing work in the landscape industry, the green industry, and what I'm teaching is really important, incredibly. The professional lawn care industry is huge, massive industry, lots of dollars out there, more acres of turfgrass, for example, in the United States than most farm crops. And turfgrass is actually the #1 irrigated crop. Yes, USDA actually counts it as a crop. And that's just the turfgrass. That doesn't include all the other parts of the landscape. So it's a big deal. Turfgrass is the most intensively managed part of most landscapes. A lot of times folks, the grass is like it's the ugly stepchild. Yeah, but honestly, the reality is that when you're dealing with the green industry, it is the big picture item in most of these landscapes. And we need to understand how to take care of it. And a lot of things we're going to talk about today is going to be focused on that. Lots of environmental concerns, especially if we don't do this stuff right. So what are the pros and cons of plants in the landscape? I always like to talk about that. There are lots of pros for the landscape. The cons are that we have products that we apply like fertilizers, pesticides, potentially can cause problems. But honestly, plants are overall good. I would hate to live in a concrete jungle. Now, just professional lawn care, people's yards, it's not nearly as intensive as sports, turf, and golf industries in terms of maintenance. It's very different than sod production because the input costs are not typically as critical as our aesthetics and functionality. So it's a little different than some of the other videos that I've done where we've talked about sports, turf, golf, sod. Now, we get different scenarios. We get some folks, they want high maintenance, the greenest grass in the neighborhood across as many weeks as possible, being able to withstand high traffic, such as golf and sports turf, as well as some businesses and homeowners too. They just want these really, the best lawn. We get the medium kind of group, which is sort of the balance of cost and aesthetics, functionality. Frankly, here at BYU, that's what our grounds, we typically want to be somewhere in the middle. My home, that's what I want. I don't want to put in all the work and effort that we do with sports turf, but I also, kind of have a little bit of pride on the line. I need to have a decent looking lawn. Low maintenance, we want a covered surface, but it's, if it's a little bit of pale green, dormant for part of the year, such as, the LDS Church, which is the sponsoring institution of BYU where I work. A lot of these churches, they don't want to take these, sacred funds that are that they use for all sorts of good purposes, and they don't want to spend it on the lawn. So, they want kind of a bare minimum. So this is my house, and I'm kind of proud of it. If this is 1 year after I installed my sod, I'd like you to notice that this is springtime. You can tell because there's not the trees haven't really leafed out much. The forsythia are in bloom. So this is, pretty early spring. But notice how nice my grass is. It looks great, especially if you kind of look at my neighbor. It's an older sod. And there's a number of reasons why my grass is so green. Part of it's genetics, frankly. Part of it is fertilizer and water and some other things too. But it is possible to have really green grass all year long. Some venues kind of demand perfections. Others can, tolerate some minor imperfections, such as, here's an aerial view of the quad at BYU. You get some, some little areas that are obviously not doing great. We work with lots of organizations such as churches and schools that want their landscapes beautiful, but they don't really want to spend one dime more than is necessary. A lot of our research that we do is focused on this low maintenance approach, along with other research we do on high intensity sports fields. So we're really looking at both. How do we do both? So one thing we need to remember is that mowing is the #1 cost of professional lawn care. It's really huge. In terms of a budget, I need to really think about that. It's like, how can I keep the mowing costs reasonable? Critical balance, having green grass without having excessive growth. Now, like in sports turf, we really throw a lot at it, and we are mowing sometimes every day, like in golf, every day. A lot of sports fields, we're mowing every other day or every third day. So we can kind of get away with some things in those intensively managed places that I don't really want to do at my house. I don't want to mow every 3 days. I kind of like to mow about once a week. Now, here's kind of a formula, just some general things. And honestly, a lot of companies don't get a lot of this right. First of all, soil testing for most of the nutrients. Baffling to me why most lawn companies don't do this. In the farm world, pretty much everybody who's still in business understands the value of soil testing and not guessing, going out there and having a one-size-fits-all formula for everybody. We end up building up really high nutrients. We can even get into toxicity situations. And frankly, we're being wasteful and we're causing environmental problems, especially when it comes to phosphorus. Now, nitrogen and sulfur are kind of an exception. The soil testing isn't as critical. I still include that in my testing, but I more or less get on a program of how much nitrogen I apply every year. I still look at the soil test, but it's managed a little differently. And I'll explain that later in another video where we talk about fertilizer. But it's really vital, especially with nitrogen, to have a steady supply of nitrogen using mostly slow and controlled release products throughout the season. The problem otherwise is I get these flushes of growth. If I go out there and I apply a quick release fertilizer, I get this big flush of growth. And then I'm mowing more than once a week, or I'm getting so much growth that I end up scalping it, with taking off more than 1/3 of the shoot. So that's my 1/3 rule. We don't ever want to take off more than 1/3 of the shoot. So that's an important part of management is kind of keeping that the nutrients, especially nitrogen. Nitrogen's #1 by far in terms of how fast we get the grass to grow. Getting that nice and steady throughout the season so I don't get crazy flushes of growth that have to be mowed. Also, we want to recycle the clippings. Putting the clippings in the landfill is unnecessary. It's wasteful. It's an environmental issue. And frankly, it's not as good for our soil. It's better to put those nutrients recycled back into the ground, as well as the organic matter. It makes a lot of sense. Now, the problem is if I end up waiting too long, now sometimes that happens, like, we get a bunch of rain and we can't get in there to mow, or something happens. We go on vacation or something, and we end up getting too much. So we might need to remove the clippings at that point. But in general, if I'm managing everything right, especially the nitrogen, and I'm mowing once a week, I shouldn't have to remove the clippings. I can recycle them in place, especially with some of the modern mowers with recycle options. Using integrated pest management and not a one-size-fits-all for this either. I'm a big fan of that. I just kind of hate, hey, let's just go out and apply fungicide to everybody no matter what. If what my counsel is to lawn maintenance companies is that let's kind of look around and see who needs it and who doesn't. Now, some places, like, sometimes we get an infestation or a fungus there. It pretty much comes back every year. So I kind of know what I need. It's a little risky not putting down the insecticides, but like at my house, I went for about 15 years without any fungicide or insecticide. Now, I still have never had to apply insecticide, but this year I got nailed and it took out part of my grass with the fungus. And so now I'm probably going to have to put that fungicide on every year. So that's a little difficult. It's a little easier for me just as a homeowner to kind of customize. It's harder when you're a lawn maintenance company because it's just a little bit more of a hassle to put that down, but it's also expensive and wasteful if you're not doing that. So I kind of like this IPM approach. I think it's important to coincide the pesticides and the fertilizers. I'm going to give an example of that where we're mixing an insecticide and a herbicide and some fertilizer all into the mix. Aeration is a key. Now, the reality is a lot of lawns don't get so very much traffic and they don't really need aeration. I've never aerated my lawn in my house. I just don't get that much traffic. And I have pretty good aeration. The ground's not very hard, but it's something I need to watch. And if I get compaction, I get poor aeration, it has a negative impact on the plants. It's also not good for people. You know, if I fall and hit my head on that, if it's hard as a concrete, then that's an issue. So aeration is important. And then water is the most important key. All this stuff's important, but honestly, if I don't get the water right, everything else goes belly up. And so it's really important, especially if I'm in an a semi-arid region, I have to get the irrigation right. So, and we'll teach all these things in some additional videos, but for a lawn maintenance company, these are all the things I got to factor in. Now, a lot of lawn maintenance companies aren't doing the water, which is kind of a problem because the most important part of what we're doing is left to somebody else besides them. And then they don't manage it right. And then the client is blaming you because their lawn doesn't look good. It's really a problem in the lawn maintenance industry. It's that it has to be dealt with. All right, now let's do the math. So first of all, stop saying you're bad at math. It's okay, I get it. It's hard sometimes, but saying you're bad at it just sort of sets you up for failure. I will tell you that math mistakes will kill plants if we apply too much fertilizer, pesticides, or I don't put on enough. You could lose your job. I know folks who have lost their job over math mistakes. I have seen lawsuits. I have loss of functionality. I have seen people die because of math mistakes, environmental problems as well. So let's get the math right. Let's make sure we're applying the correct amount of these products so that we are doing it justice and not causing problems. Now we're going to be using what I call dimensional analysis, not just me. Dimensional analysis is a common thing out there. Some of you may already have heard about it and know how to use it. I think it's important that you spend some time figuring out. There's some great, tools like Khan Academy that can teach you how to do this, but I'm going to go through it. Here's just one example. If the space shuttle can travel 17,000 miles per hour, how many meters per second does it travel? Well, what I have to do is I have to use these conversion factors listed at the bottom, and I look at these math fractions and I'm multiplying together in order to make the units come out correctly. And if I do that, if I get the units right, the math will follow. And so what we start off with is we want to convert miles to meters. And so the first thing is that there's 1.60 kilometers per mile. So if we multiply by that, when we have two things that are, if something is divided by itself, it cancels out. So that's what's happening here is that miles is in the numerator and it's in the denominator. And so it gets canceled out. Now I have kilometers. There's 1,000 meters in a kilometer. So I now multiply by this one. And now kilometers cancels out and I am left with meters in the numerator. And that's what I want. That was my goal. Now I'm going to shift gears. I'm going to focus on the denominator. I'm going to convert hours to seconds. And we're coming over here now, and 1 hour is 60 minutes. I multiply by that, the hour cancels out. And then I do the same thing, 60 seconds in a minute, and the minutes cancels out. And I am left with meters per second. And then I just do the math, 17,000 multiplied by 1.609, multiplied by 1,000. You could multiply by 1 and by 1 again, or you could just ignore that because anything multiplied by 1 is the same. Then down here on the bottom, it's 1 by 1 by 1 times 60 times 60. And if I do all that math, divide the numerator by the denominator, I get 7.6 times 10 to the third meters per second. That's dimensional analysis. Now that was kind of fast. I'm gonna go through it in more detail with an actual problem related to lawn maintenance. Here's kind of the steps. It's really important to set it up right. You need the starting units and the ending units. So getting that right, it's my opinion, that's really the most important thing. I need to line up these conversion factors so that the units cancel out. Multiply all the top numbers and divide by each bottom number. And then I need to check the units and the answer. Okay, so here's a problem. I want to determine the amount of each product to add to a 500-gallon mixture for application by a lawn care company for a 4-gallon spray per 1,000 square feet. And there's 43,560 square feet in an acre. I'm going to need that conversion factor here in a second. So this is a pretty typical kind of thing. It's a lot of times lawn companies are applying liquid products because they can mix them all together. It's a little more efficient. And so usually got a great big tank. I'm going to be applying it to multiple clients. And those have some kind of a spray device, and it's going to have a calibration based on how fast the applicator walks. So we can measure that, and this particular applicator or this particular equipment is applying it at 4 gallons of spray per 1,000 square feet of lawn. So I'm gonna now use that. Now I'm going to apply some fertilizer. I want 1 pound of nitrogen per 1,000 square feet. Half is urea and half is methylene urea. And then I want to put on 1.5 pounds of active ingredient of an insecticide and 1.7 pounds of active ingredient of an herbicide. So we're going to walk through, we'll do one step at a time. I know that seems like, oh my gosh, how can I possibly do that? It's just one step at a time, and it's really doable. All right, let's tackle the urea part of this. I've highlighted in red everything that's pertinent for what I need. Again, the steps of dimensional analysis. Let's start by those starting and ending units. Before I do that, though, I just want to point out that I like to use the unit TSF. A lot of times in the urban landscape, like in the farm world, I'm usually dealing with acres. But in the urban landscape, a lot of times the recommendations are coming at us in terms of per 1,000 square feet. Like, oh, let's apply 3 pounds of nitrogen per 1,000 square feet. Now, the thing is, though, is that this is often treated as a unit and not as a value. And so to reduce the confusion, I will often use TSF instead of 1,000 square feet in order to be able to be less confusing. So hopefully you'll see what I'm talking about here and won't be confused. It is a little confusing, but hopefully it's less confusing by doing this. Now, again, let's start with urea. Our starting units are generally what we want on the ground per unit area. So in this case, it's how much nitrogen per area of lawn, which we were told is 1 pound of nitrogen per TSF, per 1,000 square feet. So that's what I want to apply. Now, I can't go out and buy just nitrogen. I have to buy something that has nitrogen in it. And then I've got to convert it, because like if I go buy urea, it's not 100% nitrogen. It's got other stuff in it. So I've got to do some conversions. Now, for this particular problem, which is fairly common, I want to apply some of my nitrogen as a quick release so I can get a nice, quick bang out of that fertilizer. And then I want the other half as a slow release so I get that steady growth without the extra mowing, right? So we're going to multiply that 0.5 by 1, and that comes out to be 0.5 pounds of nitrogen per 1,000 square feet. That's my starting unit. Our ending units are what we actually put in the tank. I can't add pure nitrogen. I'm going to be adding, some bag of urea. Like, how many bags of urea do I need to add to the tank? So we want to know how much pounds of urea per tank. So the way that this is going to set up, it's going to look like this. This is my dimensional analysis. But let's walk through it carefully and slowly to see how I come up with setting this thing up. All right, so first of all, again, my starting unit is 0.5 pounds of nitrogen per 1,000 square feet. My ending is how many pounds of urea to apply per tank. I need to convert the starting units to the ending units by using these legitimate conversions that I have access to. So let's start with the numerator. Again, that kind of, the one step at a time. Let's kind of forget about the denominator for a minute. Let's just focus on one thing. Let's convert pounds of nitrogen to pounds of urea. The numerator in this case, again, is pounds of nitrogen going to pounds of urea. The relationship that we were told, that we know about, is that urea has 46% nitrogen in it. So here's the chemical formula for urea. It's got a carbonyl group and 2 amino groups attached to it. And those amino groups have a nitrogen atom in each one. So the bottom line is, if we add all that up, it's 46% nitrogen. And so I need to factor that in. Now I like to do it this way. There's other ways to do it, but it kind of is conceptually easier to understand that if I have a 100-pound bag of urea and it's 46% nitrogen, well, there's 46 pounds of nitrogen in a 100-pound bag of urea. So I'm going to put that down as my conversion factor. I want to put pounds of nitrogen in the denominator so that I can cancel them out. And then I'm left with pounds of urea. Boom, I'm done. One step, I've already accomplished my numerator. Now we're going to switch over to the denominator. I need to convert TSF, 1,000 square feet, to tank. Now that seems kind of confusing, but just follow me here. So the relationship that we know, there's actually 2 things we need to know in this case. First of all, the applicator that we have is spraying at 4 gallons per 1,000 square feet, and my tank size is 500 gallons. So those 2 things are going to come into play here. All right, so I'm gonna add this step here that's circled. I'm going to first divide by 4 gallons per 1,000 square feet. Now, the reason I do that is because I need TSF in the numerator. And when we divide by a fraction, you'll remember from grade school that we invert and multiply. And so what that does is, by inverting it, it puts TSF up in the numerator. And now I can cancel those 2 out. And I'm left with 4 gallons in the denominator. Okay, but that's still not tank. Now I've got to do the tank. And so what I'm going to do now is I'm going to multiply by 500 gallons of spray per tank so that the gallons cancels out, and then we can have our desired units for the denominator. So the bottom line is we get all the units to come out. I've got pounds of urea per tank. I now have strong confidence that my math will be correct. And then what I do on the math is I just take all of those ones on the top and I multiply them together. So it's, and just sometimes it gets confusing, like TSF doesn't actually have a number in front of it. It's just, you can assume it's 1 if it doesn't have a number. And I can ignore that, because if you multiply 1 by anything, it's the same thing, right? So in this case, it's 0.5 times 100 times 1 times 500. And now we also have to do the same thing on the denominator. So I got 1 times 46 times 4 times 1 tank. And that math is listed down here. And it comes out to be this number, which we round off to be 136. So I got to add 136 pounds of urea in that 500-gallon tank in order for me to get an application rate of 5 pounds of nitrogen per 1,000 square feet. So not too difficult. Now, methylene urea, it's the same thing. I would invite you to maybe go practice that, pause the video and go see if you can do that. But it's really the same thing. About the only difference here is in the percentage, right? So urea was 46% nitrogen, and the methylene urea is 38%. So instead of 46 pounds of nitrogen in a 100-pound bag, it's 38. That's it. So I just do that math, and it comes out to be 164 pounds, which makes sense, right? It's less concentrated, so it should mean that I have to use more which I do, and have to add 164 pounds of this product in order to get a half a pound of nitrogen as the slow release form. All right, now let's switch gears and talk about the insecticide. So this is a little different. Again, I've got everything in red that I'm going to be needing for this particular calculation. Here it is. Let's walk through it. Now, there's a couple of differences than what we did with the fertilizers. First of all, as is fairly common, is that the label for this insecticide is listed in acres instead of 1,000 square feet. So we're going to have to make that conversion. Second, we're dealing with a liquid product that's measured in gallons instead of pounds. So we're going to have to factor that in. Okay, but again, the concept's pretty similar. We just got a couple extra steps. Starting unit, I need 1.5 pounds of active ingredient of this insecticide on the ground, and I want that per acre instead of 1,000 square feet. So 1.5 pounds of active ingredient per acre. My ending unit is, I need to know how many gallons of this Carbaryl to dump in the tank. That's what I need to know. Okay, so we're gonna again, I'm just going to walk through this the same level of detail as I did with the urea, just so we get some good repetition here. We're going to focus on the numerator. In this case, pounds of active ingredient, and we want to convert to gallons of the Carbaryl. The relationship we have is that we were given is we were told that there's 4 pounds of active ingredient in every gallon of Carbaryl. So similar to the fertilizer, we want to get the pounds of AI on the bottom in order to cancel it out and convert it to gallons. So that's what we do. There's 4 pounds of active ingredient per 1 gallon of Carbaryl. We've now canceled that out and we are done. Our numerator is A-OK, good to go. Now let's focus on the denominator. A few more steps to get to where we need to be in this case. Got to go from acre to tank. The relationships that we have for these two is, first of all, is that there's 43,560 square feet per acre. And again, same as previously, we got 4 gallons, actually not per acre, that's a mistake, but it's 4 gallons per 1,000 square feet, and the tank size is 500 gallons. So we're going to have a 4-step process. First thing we're going to do is divide by 43,560 so that we can get acre, put on top, they cancel each other out. And now I have square feet. Now I need to convert to TSF. And so this is a step that a lot of people miss. And then they end up being off by a factor of 1,000, which is not good. So you need to multiply by 1,000 square feet per TSF. That's basically the same thing, right? So I can do that legitimately, but it allows me to cancel out the square footage, and I have TSF now. And then I just do the same steps as I did with the urea. I convert a TSF to that 4-gallon spray, and I convert to, there's 500 gallons in my tank. And then everything is crossed out. My final units are correct, gallons of Carbaryl per tank. And then we can do the math, and which comes out to be about 1.1 gallons of Carbaryl per tank in order to get 1.5 pounds of active ingredient per acre. All right, now kind of similar. We got the herbicide here. Again, everything's in red that you need for this particular one. It's also just a little bit different. It's a pesticide, but in this case, it's a wettable granule. And so we're going to set it up in some ways similar to the fertilizer because it's got 60% active ingredient. So we're going to be putting in pounds of this product in the tank and not gallons. But similar to the Carbaryl, its label is in per acre on a per acre basis. So we're going to need to figure that out. And that there's the math. I just dropped it in. The main difference is this guy right here. that we did 60 pounds of active ingredient per 100 pounds of pendimethalin in order to do the math. So that's some examples of some common things. There's other scenarios, but these are some of the more difficult ones. These are things that are important in the lawn care industry. I would say my final piece of advice: double check your math when you're on the job.